Hello, in this video I'm going to solve the following problem for you. Factorize the following expression: x times y times x plus y times z times y minus z minus x times z times x plus z. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, the final answer to the problem will be x plus y times y minus z times x plus z. Okay, so let us now solve the problem. So if I want to factorize, it means that I should be able to write this expression as a product, okay? But apparently there is no common factor that I can pull out from this term. So hopefully if I expand this expression and try to recollect them in a different way, in a different grouping them in a different way, might be I will be able to find the common factor eventually so that I can factor it out. By having this in mind, so I will multiply this so it becomes x squared y plus xy squared. This becomes plus y squared z minus y z squared. Then multiply that in, it becomes minus x squared z minus x z squared. Then I need to find a grouping that might work, okay? So what can I do? Of course, if I do this grouping, it will not work because that was the case, so I have to change the idea. So let me take this one with that one. At least I can factor a y out, and if you anticipate a little bit more, that is not that bad, because if you factor y out, then you have x squared minus z squared, which is also a conjugate pattern, so might be helpful. But at the end, factorization is not something simple if the number of terms is huge, so you have to do a lot of trial and error before coming to a conclusion which grouping or which method is suitable. Okay, so if I take this one with that one, then it might be a good idea to take these two, then it becomes y squared. In common, I pull it out, x plus z is left. So if I insist to do this grouping, then it means that I did something useless there. I have to factor it out, because now if I factor y squared out, x plus z will appear, and x plus z was already a good factor. So this means that this part is probably unnecessary, or if you want to, you can take the same grouping and do it backward once more. Because it was not very clear what I'm supposed to do from the beginning, so I have to start doing some trial and error. Okay, let us see if this grouping works. We decided to factor a y out from these two, so x squared is left from here, minus z squared is left from here. And then we decided to factor y squared from here, so it becomes y squared, and then I have x plus z. But then I put it backwards, so I factor both x and z with negative sign. Then from here I will have positive x, from here I will have positive z. So far so good. You see, at least now I have x plus z common here and there. Here is not finished yet, but that's also a minor problem, because you know that I can immediately make x plus z appear here as well if I understand that this is the conjugate rule. So what I will do, I would write y. I factor it using the conjugate rule as to x plus z, x minus z, and then I have plus y squared times x plus z, and then I have minus x times z, x plus z. So now you see I would consider this new grouping a successful one, because x plus z, x plus z, x plus z is a common factor to all of them, and then you know that whenever this happens, we become very happy if our problem is factorization, so I pull it out. So be careful what is left now. I am pulling this out, so y and x minus z both are left from this. From this one, only y squared is left, and from the last one, minus xz is left. At least I succeeded to factorize this, because now this is a product. But it is always, when they say factorize, you have to continue until no factorization anymore is possible. So this is a first degree polynomial, so you know that this is a prime polynomial, it means that it cannot be factorized more. It is similar to prime numbers. But if I want to see if it is possible to factorize or not, so it is a good idea to multiply, because you see that there is no common factor that I can pull out. With the same idea in head, I try to expand that. So this becomes yx minus yz, and then I have plus y squared, and then minus xz. Now, let us keep this aside, because that is good enough. But then I ask myself, is there any grouping in that part so that it works? And it is not hard to see, because there are only 4 terms involved. So you can see that if I can take these two, I can factor a y out, and x plus y is left. And if I take these two and factor minus z out, again x plus y is left, which is good. So let us follow that. So what I will do, I will take a y out from these two, it becomes x plus y. Between these two, I factor minus z out, this becomes y plus x or x plus y, it doesn't matter. And then you see that now this common factor, I can pull it out, so this becomes x plus z, x plus y, I pull it out, and from here y is left, from there is minus z is left. And that is the fully factorized form of this expression. The only difference is that in the answer, this factor, if I remember correctly, was the middle one, but it is no problem because the product, the order doesn't matter. Okay? I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.